Welcome back, guys. Today we're talking graphing in systems of equations. In this video, I'm going to show you all of the most important formats that you'll have to be ready for when you're solving systems of equations by graphing. And be sure to hang in until the end because there's a 2-problem test I designed specially for you guys to see if you can pass it. And if you can, then you should be ready for just about anything you're going to see on this topic. So the way you get the solution to a system of equations by graphing is just by literally graphing the two equations, usually in slope-intercept form or in intercept form, and just finding where they intersect. So the point where they intersect is actually going to be your solution, as we can see in this example here. So pretty simple actually, you just go ahead and graph the equation, so like y equals 2x plus 1. Remember how you always start with the y-intercept right here at 1, so go ahead and start at 1, put your point there, and then use this as the slope 2 over 1, so going up 2 over 1 from here, draw your line, basically like that, and then for the second one, start up here at 4, 1, 2, 3, 4, put your point, and then this time with the -1 slope, that's -1 over 1. So this time you go down 1 and to the right 1. And you'll notice you'll hit this exact same point that was our second point from our first graph. And that is actually going to be our solution. So if we graph this here and just sort of highlight what this point is, the x-coordinate of that is 1 and the y is 3. So the intersection point or the solution to this system is just 1, 3. Pretty straightforward, right? Now, if you're not a pro at graphing lines in slope-intercept form, I would highly suggest you watch the video in the description on slope-intercept form first, and then come back here after. And if you don't know how to graph using intercepts yet, or graphing in standard form, ax plus by equals c, I recommend you go watch that video first, and then come back here after. Lastly, if you're kind of unfamiliar with horizontal and vertical lines and how those look on a graph, go ahead and watch that video. All 3 of them are below in the description. Now, a lot of times, one of the equations, or even both of them, will actually be in standard form, which is ax plus by equals c. So this is a little bit more challenging for people to graph most of the time if they don't know how to graph using the intercepts. But this is a good opportunity to review, and you really don't want to avoid it because there's a tough concept coming up if you're in Algebra 2 right now called linear programming, where graphing using the intercepts is all but essential. So you'll really want to learn this. So, in this example, we've got 2x plus 4y equals 12 up here. That is in standard form. So we're going to graph that using the intercepts just so you guys are super familiar with that. So I'm just going to write that right below here so you can see that it's in the shape of ax plus by equals c. So not a big deal here. But graphing using the intercepts just means that you find the x and y intercepts by plugging in 0 for the opposite variable each time. So at the x-intercept, the y-coordinate is going to be 0, and at the y-intercept, the x-coordinate is going to be 0. So just remember, to find any intercept, you plug in 0 for the opposite variable and solve. But when you make your little table here, remember, you only need 2 points to actually graph a line. So when you find these 2 intercepts and connect them with a line, that'll be enough for you to actually graph the line. So plugging in 0 for x here looks like this. You have like 2 times 0 plus 4y equals 12, and then you've got 4y equals 12 because the 2 times 0 just disappears. Divide both sides by 4, and y is 3. So you've already got that the y-intercept is at 0, 3. Now we're just going to do the same thing to get the x-intercept, but we're going to plug in 0 for y. So now 2x plus 4 times 0 equals 12. 4 times 0 disappears because that's just 0. 2x equals 12. Divide both sides by 2. And x is 6. So now we have the x-coordinate for the x-intercept. So x-intercept's at 6, 0, y-coordinate's at 0, 3. If we just put those on the graph, it's like 0, 3 is 0 for the x, and then 1, 2, 3 for the y, and then 6 for the x for the second point. 1, 2, 3, 4, 5, 6, 0. So if we draw a line through those, basically looks like this. And then this other one's actually in slope-intercept form, so that's going to be super easy to graph. So I'm going to go ahead and use a red line for that. I'm going to start at -7 for my y-intercept, -1, -2, 3, 4, 5, 6, 7. And then I'm going to go up 2 over 1 for my next point. And then, let me actually erase that. That was a little messy. So if we go up 2 over 1, there we go. And it looks like that point is going to be at 4, 1. And that's all. So something important to note here, guys, is that a lot of teachers won't actually teach you how to graph using the intercepts. They're just going to have you convert to slope-intercept form every time. So if that's the case, I'm going to show you how you want to approach that. Remember how if something is in slope-intercept form like this, the y variable is just isolated, right? So when you're trying to convert this into slope-intercept form, you just have to get this y variable by itself. So I'm just going to sort of walk us through that. 2x plus 4y equals 12. Move the 2x term over first. So when you do this, wedge the negative 2x right before the 12 right there. That way it ends up in the form y equals mx plus b and not b plus mx. You'll see what I mean in a second. So 4y equals negative 2x, and that's a positive 12. Divide both sides by 4. And then y equals negative 1/2 x from dividing this term by the 4. And then dividing the 12 by the 4, positive 3. So when we go and graph this, we start up here at 1, 2, 3. And then go down 1 over 2, and it ends up basically looking like that. And then if I go and graph this one here again, that's at negative 7 for the starting point, so negative 1, 2, 3, 4, 5, 6, 7, up 2 over 1, and then there we go. Let me try and redo that. Okay, so roughly, there we go, at 4, 1. So same solution, guys, but again, you'll just want to do it this way if your teacher doesn't show you how to graph using the intercepts and you just convert to slope-intercept form anyway. Okay, guys, so sometimes you're going to have to make a judgment call as to whether it's going to be easier for you to solve using the intercept when something's in standard form like this, or whether it'd be better for you to convert over into slope-intercept form. Now, the way you tell is you'll actually have to realize that this number at the end, the 12 there, is going to eventually become your y-intercept when you divide it by the term that's on the y here. So when you divide both sides by 3, just ask yourself, like, is the 12 divisible by 3? And yeah, it is. We're actually going to get a whole number out of that. So we'll get a whole number y-intercept, which will make it pretty straightforward to graph. So it is going to be a little bit better to graph this using slope-intercept form if you want to avoid decimals, just because remember how if you're going to be solving for the x-intercept, you'll end up dividing both sides by 5, and that 12 isn't divisible by 5. You're going to get a decimal. So it's going to be slightly easier to do slope-intercept form. So I'm just going to get rid of this stuff here, and we'll convert it over into slope-intercept. So just getting the y by itself here, move the 5x over, wedge it right there, divide both sides by 3, make sure you hit both of those terms. Negative 5/3 x plus 4. We'll go ahead and graph this up 4, 1, 2, 3, 4, and then down 5 over 3, and draw our line. There we go. And now I'll use red for this other one, 1/3 x minus 2. We start at negative 2, go up 1 over 3, and we end up hitting that same point. So our solution here will be 3, negative 1. The second situation you guys are going to run into is where this number at the end, which ends up being your y-intercept, is not going to be divisible by the coefficient on the y term. And frankly, teachers don't give problems like this very often where you're going to get decimals when you have to solve a system by graphing. So you're not going to see this a whole lot, but basically it's your call. Like if you want to go to slope-intercept form because you're just more comfortable with that, go for it. If you want to graph using the intercepts, go for it. You'll probably have a ruler in a case like this, and they're probably not going to make the decimals all that nasty because it's just really hard to solve these if decimals are involved using graphing. Using substitution and elimination are not bad, but by graphing it's pretty tough. So I'm guessing most of you are going to end up converting over to slope-intercept form. It just tends to be a comfort point to most people. So I'm just going to go ahead and do that. Subtract the x over, and then we have negative x plus 9. Divide both sides by 2. Make sure you hit both of these guys. So negative 1/2 x plus 9 over 2. That 9 over 2 is 4.5. So we're going to go ahead and graph that here at 1, 2, 3, 4.5 as best we can. Then we'll go down 1 over 2. So see how I'm staying in the middle of the grids here? That's important. And if you wanted to do another one just to get as straight a line as possible, that's good too. So something like this. Okay. And then this one here I'll do in red. This one's much easier. So starting at negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then going up 2 over 1. We'll do a couple points here. And I designed them to meet up right there at 5, 2. So that is going to be it here. But yeah, if decimals are going to be involved, it's your call. If you guys are finding this helpful, please do go ahead and hit the like button. I appreciate it. Thank you so much. So we actually have to talk about some weird situations now, like no solution and infinite solution. They're actually not that bad. They'll be pretty quick. So remember, the solution to a system is where the lines intersect, right? So if there's no solution, that means the lines never intersect, which means the lines are parallel, which means the slopes are the same, like we see here. If you go and graph these, y equals 2x plus 4, I'll use blue for the first one. So going up 1, 2, 3, 4, and then going up 2 over 1, slope is basically like that. And then for the second one, y equals 2x minus 1, starting here at negative 1, up 2 over 1. And you can see that if I were to draw these perfectly, these lines would never intersect. So if the slopes are the same, like you're seeing here, you can kind of tell right away actually. If these two slopes are the same, they're both in slope-intercept form, so you can tell what the slopes are, then they're never going to intersect, so it's automatically no solution. But to show your work, you'd probably want to graph them and then just put no solution off to the side like this. Infinite solutions means there's an infinite number of intersection points, which basically means the lines are overlapping one another. So they're intersecting at an infinite number of points. So if you look at these, it's like obviously these two equations are the same, but what they could do is give you one of them in intercept form and the other one in slope-intercept form, so you can't really tell that they're the same line, but I just want you guys to see sort of the relationship here. So 1, 2, 3, 4, so, and then up 2 over 1, very simple. So first line looks like that, which I'll put in blue here, and then as you'll expect, the red line will start here, go up 2 over 1, and completely overlap, and I'm going to use green to express the intersection points, which are everywhere. So infinite number of intersection points, so infinite solutions when the lines overlap. Now we're going to quickly talk about horizontal and vertical lines too, because it's something you may see on these. So just so you can tell right away, see how there's no x on this y equals equation? That's a horizontal line, just like y equals a number, or a constant it's called. But basically the way you graph that is you go up to 6 on the y, 1, 2, 3, 4, 5, 6, and you just draw a horizontal line. Which makes sense because the y coordinates of all the points on here are 6. So y equals 6 actually describes the whole line, right? So I'm going to use red for the other one, which is just plain old slope-intercept form. So starting up here at 4, 1, 2, 3, 4, and then going up to over 3, 1, 2, 3. See how the intersection point is going to be right there? That's actually it right there. 3, 6. Quick example with a vertical line now. Vertical lines look like this. They're just x equals a number. So x equals a number or x equals a constant is a vertical line. So you go to where x is 3, 1, 2, 3, and just draw a vertical line. And the x coordinate of all the points on that vertical line are just 3. So it's like x equals 3 on all these. So x equals 3 describes the whole line. And then looking at the other one, y equals negative x plus 4, 1, 2, 3, 4, and then down 1 over 1, and then something like that. And then intersection point is here, so in this case, 3, 1. Alrighty guys, time for your 2-problem test. If you can get through this without much trouble, you should be good to go. First one, guys, here we go. So I'm going to hone in on this first because I want to deal with the intercept form one first. I just think the slope-intercept forms are easier, so let's get the hard one out of the way. And I'm seeing that the 18 is divisible by the coefficient on the y term, so I'm just going to graph using the intercepts. It's actually divisible by both the 2 and the 3, so I know I'm going to get nice numbers from this. Don't have to be worried about it, right? So I'm just setting up my little table here for my intercepts, 0 for the x, 0 for the y. And then I'm going to plug 0 in for x here, so like 3 times 0 minus 2y equals 18. Negative 2y equals 18. And then when you divide both sides by negative 2, y is negative 9. There's the first one, and then we got to plug in 0 for y now. So 3x minus 2 times 0 equals 18. 3x equals 18. Divide both sides by 3, and x is 6. So I'm going to go ahead and plot those points and draw a line through them. So 0, negative 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. and then 6, 0, 1, 2, 3, 4, 5, 6, and then I'll draw this here. There we go. Okay, and then this. A little easier. 1, 2, 3, 4, 5, 6, 7, 8. And then down 4. 1, 2, 3, 4. And then 1, 2, 3. And then if I just sort of want to creep up on this line here, you could do another down 4 over 3, because you can see it's going to end up nice. It's going to end up landing right there. So here we go. And this point, if you remember from the other line, was actually 6, 0. So first one's out of the way. Not so bad. Last one, guys. Here we go. So honing in on this first, because it's probably the more difficult of the two. The 30 is divisible by the 15 and the 6, so I might as well just graph using the intercepts. You know, it's good practice for the next unit, the linear programming unit, like I was saying. So might as well get used to this. Plugging in 0 for the x, 6 times 0 minus 15y equals 30. So like this is gone, negative 15y equals 30. Divide both sides by negative 15. Y is negative 2, so that goes here. And now plugging in 0 for y, 6x minus 15 times 0 equals 30. So this is gone. 6x equals 30. Divide both sides by 6. X is 5. So let's go ahead and make that y equals negative 2. No, let me put this in here. There we go. Y is negative 2, and then x is 5. 1, 2, 3, 4, 5. Draw your line. There we go. And then this guy, straight up slope-intercept form. So down 1, 2, 3, 4. And then we're going up 2 and then over 5. So up 2 over 5. And if you notice, these guys are parallel. Let me draw a little nicer one there. There we go. It's a little better. Yeah, so this is going to be no solution because they'll never intersect. Good stuff. That about does it for solving systems of equations by graphing. Be sure to check out the videos on substitution and elimination next, because that's definitely what you're going to be going on to. And they tend to be a little bit more difficult than graphing, so be sure to check those out. Thanks so much for watching, guys. I'll see you next time.